So when we first started out dealing with using the trig or using what we know about the polygons to solve for the unknown angle measures, and 1, 2, and 3 are essentially all the same thing except for they have different amounts of edges. So, anyone have a request? 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So 1 and 3 are almost the same, except 1 is an octagon and 9 is a nonagon. So if we look at 2, since 2 is kind of more unique, how would I solve for this angle 1? And they actually name their angles in the order that you want to solve them. Caleb?
Well, you know that if you, assuming it's a regular polygon.
Yep, they tell us they're regular.
They're regular. Then if you take the number of sides, so I won't count.
Hey.
So 10. If you take 10.
Decagon.
Each side, well, each little thing, I don't know what you want to call them, angle, I guess you could say, has to be part of 360 degrees.
Yeah, an equal part, right?
Equal part of 360 degrees. You can assume that if you just divide by 10, you'll get your answer.
Yep. So we take our total 360 divided by the number of edges, in this case, which is 10, and we get that that angle would be 36. Then, to solve angle 2, we just divide by 2, cut it in half. And to solve angle 3, we use our triangle angle sum theorem. So 1, 2, and 3 really, once you solve for angle 1, the rest of it should be fairly straightforward. Now, in our next set, when we're asked to find the area of the regular polygon, and almost all of the work we do assumes that the polygon is regular, we have the apothem A, which the apothem versus the radius. The apothem is like your long side of the triangle, whereas the radius, which some people are like, no, it's not a circle, it can't. Radius is distance from edge to vertex, so it is essentially your hypotenuse. So if we have a pentagon with an apothem 1.6 and a side length of 2.4. Sorry, actually, does anyone have any requests for which one of these we solve? No. Okay. So all we need to do is take half of the product of the apothem times the perimeter. So the big thing here is finding the perimeter. If we know it's a hexagon with a side length of 3, the perimeter, hex is 6 sides with side length 3, the perimeter would be 18. And then we use the apothem times the perimeter, cut it in half. Same thing here with like a nonagon, that's 9 sides with a length of 4.1. So we would get 36.9 as the perimeter. And again, apothem times perimeter divided by 2. Any questions on that section? Any problems you'd like to see? Did she actually effectively review the homework with you guys yesterday?
No, she didn't.
Like the 10 page, like showing you all your answers?
Oh, she didn't even do that.
She turned off.
No, she said you could come up when you were done and check it with her, but
So Mr. Hull, Hull, was supposed to be your sub, the guy who's been here before, kind of like military type.
oh yeah, he's so great.
Yeah, that's why I thought it was going to be an okay day and I could actually leave things for the sub to do, as opposed to just making a video and whatever else, because I thought Jimmy was going to be here and he likes teaching you guys.
Yeah.
So, my apologies. Sometime between Friday and yesterday morning, my sub got switched because it was supposed to be Jimmy. So, we'll pull up those answers for the rest of your 7 here in a minute.
She was well.
Interesting. It's okay. Let's move on. We don't need to talk about the past. So here, find the area of each polygon. We can still do the same thing if we want, but in 9. So we know a triangle formula that involves the height, right? 1/2 base times height. It's easier to just apply the formula that we have here, because to solve for the height, you'd be solving for an unknown leg of your right triangle. Like if you were going to try to use your triangle formula, because every year people are like, can't I just use 1/2 base times height? Sure. But to solve for that height, you're going to end up doing more work. But what is that height? What else do we call the height? The apothem. This is the same formula. I was waiting to see it on somebody's face, but I don't think we're getting there. The apothem is your height because it's the altitude.
No, the apothem is from the midpoint.
Ah, the apothem is the height from the midpoint. So, what is your height compared to your apothem?
It's apothem plus radius.
Ooh, it's the apothem plus the radius. So we really have two options of one's hard, one is also hard. We can solve for the height, we can solve for the apothem. Anyone have opinions of what they think is easier? If we solve for the height, we could do 9 squared minus 4.5 squared and take the square root of that. So, I mean, that would be fairly easier. Or it tells me that the apothem is the longer leg divided by radical 3. Carmen? Sure.
I did like this. Emma actually showed me how to do this, so Emma showed me.
Props to Emma.
Yeah.
It's okay if it doesn't look perfect.
Yep, there it is. Okay. And then this is like, so this is the apothem. And then I like solve for this. Wait.
Yeah, so here the apothem, would it be a short leg or a long leg of the triangle? It'd be the short leg here. So continue.
And so then this like leg would be 9 divided by 2, which is
Which is what they got for their longer leg of the triangle. So why do we divide by radical 3?
Because the longer leg on a 30, 60, 90 triangle is radical 3 times larger than the shorter leg.
Because it's regular, we know that each of these vertexes is 60 degrees. So if I look at just this angle, that's 30 degrees, and I have a 30, 60, 90 triangle. So guys, these problems, there's a lot of different ways you can approach them. This will always work. There's other routes that we could take specific for this being a triangle, but here they derive that their longer leg is 4.5 by knowing it's half of 9. The apothem in this case will be a shorter leg. So to find the shorter leg, we just take our 4.5 divided by radical 3. And that would be some awkward value. Is it really bad?
It's David.
It's the HVAC system. It's like literally the air flowing. You can just hear it. No. Well, you might be going crazy. I don't know. But the noise is not because you're going crazy. Everyone thinks I went crazy, and that's why I teach middle school. So one other way, like let's say we look at 10, and I choose not to use the main formula there. I know that it's regular, so that's 8. So I could derive the height by just doing 16 squared minus 8 squared, square root of that, and then do 1/2 16 times that height. If I use their method, my vertex, Megan?
Didn't you only solve for the apothem?
Yeah, I mean, we can plug in and solve for the
I was
area.
just wondering if you thought you were covered.
No, I didn't take it all the way. If you want to take it all the way, your perimeter, 9 times 3 is 27, then times 1/2. What'd you get here?
I was wondering.
Anyone get a final answer for 9?
35.1.
Yeah, 35.1 if you round it.
Yeah.
And that would be a unit, feet. So again, any regular triangle will end up making a 30, 60, 90 special right triangle. So this right down here, we have a longer leg of 8 and a shorter leg that we don't know, and that's our apothem. And then some hypotenuse that we don't really care about, that's our radius here. So this works because it's the 30, 60, 90 relationship. So you can just take your 8, divide by radical 3, that'll give you the apothem. Do I need to do 11 or 12? Traveler. Knock it off. Get out your paper.
All right.
Anything from the back that gave us difficulties?
Yeah.
Yeah.
Let's start.
Which?
Can you do 17, 18, 19, or 20? Can you do like one of them?
17 has kind of messy values in it. Find every area of each polygon with a given vertice or given radius or apothem. Oh, so all of this is just taking the one value that you had and working from there up to all of the other values that you need. So if we have a hexagon here, I want to first talk about what is this top angle. Well, if it's a hexagon, then we really took 360 and divided by 6
It's 6.
to find one of these entire angles,
Which means it's 30.
which means that angle up in here would be 30, which means we have a 30, 60, 90 right triangle. I know my long leg of my 30, 60, 90. It's 2 radical 3. How does my long leg compare to my short leg or to my hypotenuse? Do I have a relationship that I can use to connect them?
Yes, you can divide your long leg by radical 3, get the short leg.
So what you're saying is that the long leg was normally short leg times radical 3. So to find short leg, it's long leg divided by radical 3, which in this case
2.
just gives me 2. So then I know that each edge is actually 4, which leads me to knowing the perimeter is 24. Any questions on how I made those jumps? We identified that the long leg, we'll call it big L, will be the short leg divided by radical 3. And we knew that because we had been told that I wrote this backwards. We knew this because we know the long leg equals radical 3 times the short leg. Every now and then, dyslexia gets away. So, questions. Once I now know my apothem and my perimeter, multiply together, divide by 2, you have your area. Same practice for essentially all of these. Here, be careful, that's a radius, not the apothem. So if you drew your triangle down here, this would be the 8. And your apothem, we don't know it yet. We know the hypotenuse.
Wait, so how do we figure it out?
I bet you at some point you'll have that light bulb turn on. What would that be? 60, right? So what would this be? 30. So if we know that that angle's 30, ooh, my elbow touched. And when it multi-touches, it erases. So I have a 30, 60, 90 right triangle. I know the hypotenuse. What relationships do I know about the hypotenuse in a 30, 60, 90 right triangle? So you can go back and check those notes if you can't remember. We said in a 30, 60, 90 that the hypotenuse, we talked about how we could find the hypotenuse. What was our formula? Hypotenuse will be, do you remember it, Michelle?
It was times 2 of the short leg.
2 times the short leg, right? So your hypotenuse is double the short leg.
Yeah, it's double.
So my short leg
Yeah.
has to be
4.
4. Then I still need my long leg, and we know that your long leg is radical 3 times your short leg.
To be 4 radical 3.
So it'd be 4 radical 3. So then I could actually just multiply that by 6 if I wanted to get the perimeter. Does that make sense why we would do that? Because that's half of the edge. That 4 radical 3 is from here to here.
Why are you finding the perimeter?
Because we need the area.
Oh, okay. So,
If we're going to use the area formula, that is 1/2 the apothem times perimeter. Otherwise, you take your 4, add it with your 8, you know your height then, and you can use the other triangle area formula options.
Wait, since we're doing half, wouldn't we just do times 3?
Ooh, if you want to go ahead and compensate for that. Yes, you can go ahead and do that, but I wasn't going to skip steps like that. Because if I want to find the perimeter, I could take that value times 6. But if I go ahead and plug it all in, then I could just multiply it by 3, compensating for the half.
Okay.
Now, unless we have any questions on these that we want to go over, I'd like to show you all the answers because she was supposed to do that yesterday. It's really annoying. Because that is just like, so my plans that I left for her were to show you all the answers and have you guys mark any questions that we needed to discuss today. And the first thing we were gonna do today is discuss any of those questions if that's how you voted. Otherwise, I was going to wait and do discussion prior to the test. Our mastery for Chapter 7 is going to be on Friday. So I would like to show you all the answers right now and deal with like what do we need to review, whatever else, and give you guys a couple days to deal with that. But then we can decide, do we want to take questions right now or do we want to hold off on questions till like Thursday? But does anybody want to see 22 through 26, any of those? Rhea.
Okay, can you do 24?
24, I hope I can.
Excuse the interruption. Could I have Caleb Smith to the office? Caleb?
There is a Caleb in 7th grade now.
Yeah, he's my Webby.
So what we need to do is figure out the area of one of these tiles. What we need to do is figure out the area of one of these tiles. And then if we know the area we need to cover, we're going to take the total area, divide by the area of each tile. Each tile has a radius of 1. So if I draw that like triangle, I've got my hypotenuse. And because it's in a regular polygon, we can derive this top angle by first deriving the middle angle, which they're hexagons. So we take our 360 divided by 6 and get 60. We divide that by 2 and get that this is 30. So we know that this bottom edge right here will be my short side now, and my apothem will actually be my long side. So in a 30, 60, 90, how's the hypotenuse relate?
2 times.
Double.
Did you say 3?
Said 2 times.
Okay, making sure. I thought it sounded like a 3 through your hands. So this is 2 times your short leg. This would then be 0.5 or a half. The long leg is radical 3 times your short leg. So it's half of radical 3 or radical 3 over 2 if you want to. This short edge of 1 really corresponds to half of one of the edges. So what would the entire edge there be? 1. So this is actually a really cool hexagon where its radius is the same as its edge length. So the perimeter here would be 6 because we have a hexagon.
Wasn't that bound to happen if that's going to be, if half of it is half, then would it, wait, would it,
You're on the right track. Keep thinking. Keep going.
wait, then so if it's supposed to be like 2, then would it then half be 1, so then if you double, wouldn't that just be 2?
In a hexagon. Yeah.
Oh.
Because what we really get here is an isosceles triangle, where the hypotenuse of our right triangle is really the edge of a 60, 60, 60 equilateral triangle. So this right here is an equilateral triangle, so that radius actually tells me what the edge length is. So in a hexagon, this is our our conjecture right now, right? What we think is true based off what we've observed. In a hexagon, if I know the radius, that should correspond to my edge length, is what you're saying. So we would want to try that a couple more times to verify it, but that would seem to hold true because if I chop it in half and do my 30, 60, 90, then I really can double it and get my equilateral. So then my perimeter for each of them is 6. My apothem, we had said, was radical 3 divided by 2. And do your apothem times your perimeter, chop it in half. So apothem times perimeter, I'm going to get 3 radical 3. Then when I chop that in half, I'm going to get 3 halves radical 3 for my area of each one. And that would be inches squared.
Yeah, you have to find feet and then 48 divided by.
So here's the last trick part of this.
Or you could give
48 square feet versus square inches. These are very small tiles. They're an inch from the center out, so they're maybe about 2 inches big. So what's the conversion factor from feet squared to inches squared? Brian?
12.
No.
What?
Picture a foot squared. So if I were to try to draw as well as I can try to draw, because my sister, darn her, took all the artistic ability, a foot by a foot.
144.
It's 144. So be careful with your conversion factors, because when the units get squared or cubed or whatever, the same happens to the conversion factor. So if I want to go straight from 48 square feet into square inches, I have to actually use 144 for my conversion factor. Rhea?
Wait, how did you get the 3 divided by 2 with the radical 3? Like, wait.
So this, correct. So I found my perimeter was 6. My area will be half the apothem times perimeter. My apothem was radical 3 divided by 2. So I went ahead, half times apothem radical 3 divided by 2 times perimeter of 6. This 6 divided by 2 gives me 3. And then I have to divide by 2 again, so I get 3 radical 2 divided by 2 when I compute all of this through.
3 radical 2 divided by 2?
Or 3 divided by 2. 3 halves radical 3. It's a better way to say it.
It's a big bathroom.
Hmm?
It's a big bathroom. 48 square feet.
Not, I mean,
So that would be like 6 by 8 feet.
yeah. That's not that. Picture you gotta fit in a toilet, a vanity, and a shower.
My bathroom.
It depends if it's a half or whole. Yeah. So this, if we convert it into square inches, would be 48. You got it.
Pretty sure it's 6,912. Like, my bathroom is huge.
So if that's the total area, and each tile takes up this amount of area, we could just divide, and I would use parentheses because this is a mess. 3 halves radical 3. This will be a very awkward answer. 1.5 times radical 3. 2,660.4. So in total, we would need 2,661. Since you can't purchase a partial tile, we would just round up.
Nearest. So wouldn't it be?
Well, okay. Their answer would be 2660, but that's not the practical math. You can't round down a tile and leave a part of the floor without a tile. So I would round up. This is where my answer would be different than theirs, but that's why I would not mark you off if you put 2660 or if you put 2661. You're still right there. But when we think about the practicality, it makes sense to round up. You'd rather have extra supplies than not enough supplies.
Normally, don't you buy like extra?
You normally, at least when you're doing a floor type project, will be buy 5% extra for cuts and mistakes.
So that way if you do
Now, when I did my wood floor, had measured so precisely and forgotten a couple sections that when I went down there, I told the guy, look, I want to do like 10% over. Like, I know that they're like, I didn't measure that closet. I didn't measure that little corner. And the dude was like, oh, no, it's fine. If you like, you said you teach math, let's just do 5% over. I got to the end of the project, 1 box short. If he had let me do my 10% over, I would have had a box left over, but that's what you want. You want a little bit of stuff left over. So I had to drive back to Lumber Liquidators, tell the guy he should have listened to me, and buy 2 more
You
boxes.
specifically tell him.
Yeah, I seriously did. I was like, hey, remember me? He was like, yeah, how'd your project go? I'm like, great. Except I ran out 1 box short. Wasted my gas. All right, any other questions on this? Gas is expensive. And Lumber Liquidators is over, like, across town. There's only 3 of them in Columbus.
Your precious time.
Yeah, and my time is honestly the thing that matters most. Get out all of your homeworks from this chapter. After this chapter, I will probably just start posting the answer keys on Schoology and requesting that you guys check your own work.
Alright, cool.
So can we work on honor system with that?
Yeah.
Yes, you can.
That's what we did during summer.
Yeah, that's what we did.
Yeah, I know. But summer's so condensed, we really have no other choice. Since we see each other every day in here, I do kind of have the alternative choices.
I cannot
Wait,
imagine
can
it
we
give us
check
the
I like checking them in class. We can easily
Even
ask
if we do look at it.
But so here's what we would do. You would check them outside of class, and then when we come here, all you would do is like you would start by immediately asking me questions. So instead of like you need to check your work and then ask questions, we would just dive right into questions. Did we do G or K for 7-1?
G.
And can I please make one more request of next to where it says practice on each of these, put the 7 point whatever it is. So for Pythagorean theorem and converse, that was 7-1. Please write it on there. Yeah, that one was odds or evens. Zoom in a bit more. Check through 13. And then if there's no questions, we will shift the entire page. Actually, let's just check right now all of them, because I don't know, I would like to at least get done with all of the checking. Then we'll do questions. So if we need to carry over to tomorrow, we'll carry over with questions. 1 through 13. Can I shift on?
Yes.
All I want you to do is mark in, is it right or wrong? Can you figure out your mistake, or do you need my help? And I move to the back.
No, I didn't see it for like the view.
You can move to the back of
Can I shift? All we should be doing is marking if it's right or wrong. If you don't have it answered, that's a different issue. Try to get 18 through 28.
Can you go over the Pythagorean triple again?
Yeah, I was confused. About
So
that
it's 3, 4, 5, or any manipulation of it. So
too. I was
hold
really
on.
confused on just how you figured that out.
Find a third whole number such that the 3 numbers form a Pythagorean triple. So you have a longer one and a shorter one. So you can either have long leg, short leg, and then find the hypotenuse, or you could have hypotenuse and one of your legs and derive the other leg. So you can manipulate this a few different ways. You can either think of having to find the hypotenuse and take your 2 values, square them, sum them, and then take the square root. So like 18, my 2 options for that would be, if I was looking for a hypotenuse, that would be a third one. 13 squared plus 84 squared. 13 squared is 169, but 84 squared gets really bad. Or sorry, that wouldn't be. Yeah. So 84 squared. It's gonna be giant. 7,056. And I add these together. I get radical 7225. And that, when I take its square root, comes out to be 85. Now, if I had thought that 84 was the hypotenuse, and I tried to solve for the long leg, then solving for the long leg, I would set up 84 squared. Is equal to your 13 squared plus something squared. I would do my 84 squared, my 7056 minus my 13 squared. This gives me 6887 would equal b squared. And when I square root that, we get 82.98795093. Does not work. So one method will work and get a whole number output. The other method won't. So that then tells me these were both legs. We found the hypotenuse. Here, again, both legs we found the hypotenuse. The other one would not have worked. Both legs found the hypotenuse. Again, actually all of these end up finding the hypotenuse. So lucky that if I try the same method first on each of them, it will work.
Is the easy way to determine which one?
I mean, this is a manipulation 4 times it. So that one's easy to see, but all of these are a manipulation of 3, 4, 5, I believe. Actually, let me check.
Was number 23 was also a manipulation 3, 4, 5?
4.3.
Well, they're all supposed to. You had 22.
Yeah, I don't know exactly what they're like.
22 is special.
Not 100% certain exactly what they were going for, but really all we were doing here is solving for the hypotenuse.
Yeah. So like for 21, I couldn't figure out how you could manipulate 3, 4, 5 to get those numbers.
Yeah.
So I put n.
Excuse the interruption. Could I have Josh Malik to the office? Josh?
So if they had if they were really asking for Pythagorean triples that relate back to the 3, 4, 5, this isn't accurate for all of them. So they're not all going to be manipulations of 3, 4, 5. Like 23 is 3, 4, and 5. 19 is 3, 4, and 5. But they aren't all. So I don't actually like how that problem's written. (24 through 30). Can I scroll? We good through 33? All right.
Wait. For 31, I got a different answer.
If ABC is an acute triangle, two of its sides measure 11 and 14, what is the range of the possible third side? So, these two sides, if we have an acute triangle, and this is not going to be drawn accurately, so do not pay attention to how it looks, just pay attention to the math. So let's say an acute triangle, and we could have measures of 11 and 14 and be solving for another short side, which this hinge can only open a certain amount to stay acute, or we could have 11 and 14 and be solving for this side, which would end up the longest of all three. So essentially, why did I draw it like that now?
Because now there's a hypotenuse.
Okay. So what if I solve this like it's a right triangle and I have short leg and long leg? Actually, no, let's solve it like a right triangle if I have hypotenuse and short leg first. So 14 squared minus, the difference between, so let's solve for b. 11 squared plus b squared equals 14 squared. I'm essentially going to do 14 squared minus 11 squared and then square root that. So b squared is going to have to be 75, which means that the square root of that is 8.66, approximately. How'd they get to 8.7? Because if I plug in 8.66 here, what type of triangle is that?
Right.
A right triangle. If I make this instead 8.7 or 8.8 or 8.9 or 9 or anything like that, this is going to kick out a little bit further. And now what was a right angle is now what? An acute angle. So if you really want to be precise, this would be 8.66. Cannot be the length, but if it's bigger than 8.66, then you're okay, because then it's no longer a right triangle.
So it should be 8.7. Well,
So they just rounded.
no, yeah, I know.
But then I do the same thing, but instead of solving for a leg, let me capture this real quick. I leave my 11 where it is, but now I make my 14 my leg. So now 11 squared plus 14 squared, and we take the square root of that. Square root of 317 comes out to be 17.8. So there they didn't have to round. If this is 17.8, it's a right triangle. To bring this edge inward, anywhere like there or there or there, that 17.8 needs to get smaller. That's why x has to be less than 17.8. So you solve the two different ways: if it was an unknown leg, if it was the unknown hypotenuse, and then tweak it to make it acute. So it cannot be equal. It either has to be more than the leg we solved for or less than the hypotenuse that we solved for. And this actually goes back. You have two triangle inequalities that we had in our notes from this section, where if it's an acute triangle, the a squared plus b squared equals c squared changes to either the greater than or less than, depending on whether it's acute or obtuse. So you have those formulas actually in your notes. Any other questions? Yeah.
30.
We just did 30. Oh, sorry. No, we did 31. 30. A line of rows forms a diagonal.
Like, I understand. I don't know. I got it wrong. And
What is the length of a perpendicular side of the garden? So I think really just what they're doing is they gave you the hypotenuse, and you're solving for the other leg. So they're giving you 18.4 and a leg of 13, and you're solving for the other.
yeah.
So we're going to take our c squared and subtract away our a squared. That gives me 169.56.
Yep.
But that is like, our calculators dealing with squares and square roots are often not exactly perfect. So when I take the square root of that, you get something not quite perfect, right?
Yeah.
You get 13.02152. It's approximately 13 because they say to the nearest tenth of a meter, it'd be 13.0 because the 0.02, like what I actually get is 13.02152. But when I round to the nearest tenth, so this is not a perfect
Yeah.
isosceles triangle, but it's very close.
Okay, I got that answer just in a different form.
Okay,
Thank you.
you're welcome. Anything else from this sheet? Sweet. Move on to 7.2. Did we do G or K there?
Okay. Wait.
That's 7-3.
Ah, that's why you should write the number on it.
Sorry.
So up here next to practice,
I don't have it.
you don't have it. How do you
Remember
not
I was
have it?
here?
After
I
camp, correct?
gave them all away. At least I thought. And if you didn't get, oh, hey, look, maybe it's right here where all of our extras go.
Ah, I
Hey,
know
look,
it.
special right triangles reserved for Caleb.
Oh, yeah.
Do you have more than one?
I do. So both of you gentlemen probably grabbed one of them and not the other, or something like that.
I didn't even grab it.
Then you both might also need that. If I were to guess,
Yeah.
you have the notes.
32. He was here. I wasn't here.
Interesting that you don't have that. You both don't have the homework. We gotta try to knock that out tonight then. This should be pretty quick because this was just applying formulas. 1 through 6, are we good?
Yeah.
7 through 14. Ethan, you checking? Hmm?
I don't have it done yet.
For
Why?
I'm really good at other stuff. I'm gonna get it done soon.
Okay. I'm gonna assume that you've had 0 free time to get it taken care of.
I don't have anything.
Wait, what?
wait,
Back to front?
on
Yeah.
9, I got 90. Oh.
When you have 2 legs that are exactly the same, you know that it's gotta be a 45-45.
Okay. Oh. Okay.
Did you like actually try to compute math or something to like justify? Did you try to square these or something like that?
Maybe, I don't know.
Don't overthink it. Yeah, you see 2 legs are the same. If it's a triangle, it's going to be 45-45-90. Can I go to the back?
Yeah.
We're running out of time, so we have 2 minutes left to try to get through as much as we can. We'll take more questions tomorrow. I just want you guys to check right, wrong right now. Just check right, wrong real fast. Mr. Essex, can you think of a time that you've actually applied this sort of knowledge in like projects or things like that, triangles and angles?
Put a bathroom floor in.
Yeah.
Mm,
I was telling about I had to cut the trim piece to go up against my stairs, like where the angle starts, and I did trig to solve that.
I just Moki, but I mean that seems
You
complicated.
do it the lazy way.
Yeah.
they we had a tree cut down in the backyard, and he wanted the guy who the arborist wanted to see if they needed to bring the bucket in, and he estimated the height of the tree
Yeah.
by this.
So those same models that we've been using where if I stand here and I look up and I know this angle is a certain size and then I know my distance, I can approximate how tall the tree is. That exact sort of stuff I've seen get calculated accurately and a tree fall like exactly how it should and get calculated incorrectly and take down part of a building. So if you said, oh, the tree's fine, we can fall it here, and you cut it down and you hit somebody's building, you're liable. So you better do your math right.
How close are you to the tree?
I couldn't measure the actual height of the tree, but I'm assuming he had a thing where he stood, like he spotted it and he raised the thing up, and then a number came on it.
So it was probably a device that did the
sweet.
trig for him.
Yeah.
Yeah. So if it's got a laser to shoot to the bottom and a laser to shoot to the top, and it knows the angle that it opens up at, and the laser can figure out how far away things are, your hypotenuse and your leg, or your adjacent, you can solve cosine real quick. So it probably just ran a code automatically to run the cosine and figure out your unknown length. Or actually, you'd want to use either sine or tangent so you don't know the height.
See, I wouldn't do the math. I'd have that into the math one.
Yeah, but you have to get to the point where you can afford things like that.
Somebody
Which,
had to write the code. I mean, the code
Yeah.
written for that is this. Like when you write it, yep, that's built into it. So.
No, but I don't have to. I guess that's the point thing.
Brian enjoys being a poopy 8th grader where he thinks I'll never use this. And I'll enjoy 10 years from now when you actually come back and you're an adult and you can say thanks for my education.
Brian said he wants
All right, that's all we can get to today. We'll pick up on 7-3, checking work, taking questions. If we get a chance, we'll start 8-1 tomorrow. Thank you, guys.